there's a reason why we see different trends as we go down a group? Does anybody, Dominic, anybody? Very good, the energy levels increase. Therefore, what happens, Ryan? I saw your hand up as well. The radius gets larger, very good. The radius gets larger. What did we learn about that it has a two-word name, okay? And it's the cause for the protons in the nucleus not pulling as strongly on the valence shells. What's that word, the term that we learned? Electron shielding, very good. Gabe, I saw your hand up too. What is electron shielding?
Electrons on the outside of the valence shell getting pulled away.
Yeah, they're not necessarily getting pulled away more. Fix the wording, Casey, what he just said. He said that you're right to an extent, but Casey, Gabe said the electrons, because of electron shielding, the electrons in the valence shell are being pulled away more. There's something wrong with that. What's wrong with that? You don't know. Gavin, can you help your friends? Exactly, they're being pulled in. They're not being pulled away, but the nucleus, the positive charge of the nucleus doesn't have quite as strong of a pull. Now, let's get to today, okay? So now we're going to be over here. Ready, girls? All right. All right. If everything that we said is true, okay, regarding the pull of the protons not being as strong on the outer electrons, okay, because of electron shielding, I want you to make a prediction, Catherine. What do you think is going to be, as we go down a group, we're going to do the alkaline earth metals today. Which ones are they again? I always forget. The what? The second one. What are the first ones called, Lauren? Very good, the alkali. So today we're doing group 2, the alkaline earth metals. As we go down a group, we're going to look at their reactivity. Compare their reactivity. So, Catherine, we haven't done it. You're off the hook if you don't know the answer, but based on what we've learned, what do you think is going to happen? Will reactivity increase as we go down, or will reactivity decrease? And defend whatever answer you give. Why? Okay, so you say increase, and you have no idea why. Gabby, do you agree? Why? They're adding more shells. They are adding more shells. You missed a question, so you're off the hook, right?
The one that you just asked right now?
Yeah, were you here? I'm sorry, I thought that you would have walked into the room. So what do you think would happen, Afia, as we go down a group? You weren't here yesterday, so I'm guessing that you probably...
Like down this one?
Down any group of the periodic table, down any group, what's going to happen to reactivity? You feel like it would decrease? How come? Okay. How about you, Kylie? Okay, so the energy levels are increasing, so you think it's going to increase. Is that what you said, or decrease? Increase. Okay, so why would it increase then? Because of the energy levels? Like, what cause would that have? Okay. Yeah, I mean, this is all we're surmising here. We're going to bounce ideas off one another. Yeah, Ryan?
I think we'll stay the same because I'm in the same balance.
Okay. Okay, you think they're all going to stay the same. Aiden, any ideas over in your new area of the classroom?
I mean, everyone already answered.
So do you agree with any of them?
Could you repeat the question?
What do you think is going to happen to reactivity of the elements going down group 2? Okay, well, as we try to react them, will they react more as we go down? Will they react less? Will they all be the same, as Ryan said? Okay. So, you have a reason why?
Because it'll be easier for them to react since it's like they're farther away.
Okay, so very, very good answers, okay?